Hello everyone, my name is Hemant Kumar. I am from RJK University. This is a project video of my microcontroller based washing machine simulation using PIC16F877A. The agenda of this PPT is introduction to what is embedded system and internship goals and the embedded system overview, tools and environment that I have used, and the system design, demo and screenshots, challenges and learnings, and conclusion and reflection. During my internship journey at MITEX, I focused on embedded C programming and built real-time systems using PIC16F877A, learning digital input-outputs, timers, interrupts, LCDs, and keypad interface. Developed a complete simulation in PICSimLab. There is a daily coding sessions and a toolchain exploration. Thank you for this great opportunity, MITEX. In the first week of our internship, we have mastered the control flow, if, else, and switch cases, developed logic with loops, recursions, and arrays, practiced modular programming using functions, and explored different types of memory uses through strings handling and pointers, transitioning C knowledge into real-time embedded scenarios. Here is the core concept that we have learned during the first week of our internships. I will explain one by one. First, data types and variables. C provides several built-in data types like int, float, char, double R to represent integer, floating point number, characters, and double precision numbers respectively. Then we have control structures. Control structures determines the flow of execution in the program. Conditional statements like if, else if switch allows decision making, while loop like for, while, and do while enable repetitive executions. Then we have functions here. Functions are reusable blocks of code that perform specific tasks. They help modularize programming, making them easier to read, debug, and maintenance. Then we have array and string. Arrays are a collection of elements of the same data type that continuously memory location. For example, int score 5 creates an array of 5 integers. Strings in C are arrays of characters ending with a null character /0/0. Pointers. Then we have pointers. Pointers store the memory addresses of other variables. They are powerful tools for dynamic memory allocation, array manipulation, and function argument passing by references. Then structures and units. These are the advanced concepts that we will not use in this internship. What is a real-time embedded system? Real-time types of embedded systems: standalone, real-time, and mobile network. Digital inputs are pull-up, pull-down, and resistor logic. Memory types are RAM, ROM, and EEPROM and flash. Switch debounce handling, edge triggering, and level triggering. Introduction to real-time constraints and system responsibilities. Then next, during the internship, then we have to do simulation debugging skills. During the internship, I have developed a real-time system in Pixel board, used MPLAB XIDE with XC8 compiler, designed CLCD and keypad interfaces virtually, configured timer 2 and accurate delay logic, practiced ISR. ISR means stands for interrupt service routine debugging, tested edge conditions, buzzer control, and input filters. What makes a system embedded? What is the primary question? What when we doing the internship? What is what is embedded system? Combination of hardware and software for dedicated task is called embedded system. Emphasis on timing, reliability, and resource limits. Uses in automation, consumer electronics, and industrial control. Driven by microcontrollers like PIC16F877A. Prioritizes low power and tight integration. Requires efficient memory and code structure. Introduction to PIC16F877A. It's a 8-bit RISC microcontroller from Microchip, operates on 20 megahertz 35 instructions. Features are SRAM has 368 bytes, EEPROM has 256 bytes, and for digital input output 5 ports A to E, ideal for simulation due to simplicity and flexibility. Here is the additional information about PIC board. Tools that are powered my projects are my MPLAB XIDE, X8 compiler, PIC board. I will explain one by one. MPLAB XIDE is an integrated development environment developed by Microchip Technology for programming PIC and DSPIC microcontrollers. It supports code editing, debugging, and device programming across several operating systems like Windows, Mac OS, and Linux platforms. The IDE integrates seamlessly with tools like MPLAB code configuration and compilers such as XC8, XC16, and XC32. Then we have X8 compiler. X8 compiler. X8 compiler is a microchip's C compiler designed for programming 8-bit PIC and AVR microcontrollers. It translates your C code into optimized machine instructions that run efficiently on resource constrained embedded systems. Then we have PICsim Lab. PICsim Lab is a very real-time emulated design to simulate development boards like PIC, Arduino, STM32, and ESP32. It integrates with tools like MPLAB X and AVR GDB. Then we will move forward to project objective. The project objective is design a washing machine logic by controlling by a keyboard and displaying the output and turn on the fan and buzzers when the with washing machine logic. There are several wash modes here. There are 12 wash modes, 12 wash modes, and water levels. There are 5 water levels, and it is a timer based control, and LCD and buzzer alerts and fan alerts. Safety check, door must be closed. Safety, it also has safety check. Here is the what's the logic of washing machine. Here we can see that when normal switch 4 is pressed, it will scroll down. When the switch 4 is long press, it go to the next mode, and the switch 5 to control some of the things. And every time we have to check door check. If the door is opened, then we have to turn on the buzzer and show that the LCD to door open. Then when the door closed, we have to go to the logic. There are 5 different levels: high level, auto level, medium, and peak level. Hi everyone, my name is Nima. Here I am here to explain the source codes and the header files of my project washing machine simulation using PIC16 the 877A board. Here we have header files. We have CLCD. It's a CLCD H file. We have to define a line 1, line 2, line 3, line 4, and we need to define some of the things that we use in the screens. Then we have digital keypad.h. Here we have switch 1, switch 2, switch 3, switch 4, switch 5, and input line has this, and all release is input lines. Then we have main.h. Here we have to define macros of washing machine screens and water level screen, start stop screen, and update cycle phase. And also we have to use reset flag macros. Those are reset wash program screen, reset nothing, reset water level screen, reset stop screen, reset start program, and pass. And we have to also define fan DDR, buzzer DDR, which is which that is S2 and Trisk one. These two things are from datasheet of PIC16F877A board. Uh, if we put is Trisk as C2 is equal to 0, it means output. It takes fan as output, and buzzer if we put is 0, it will take as output. And if we put RC1 is equal to 0, it will turn on. RC2 is equal to 0, it will turn on the fan. Turn off the fan, sorry. Then we have timers.h. Here we have to call init timer 2, which is a function in timers 2. Then we have washing machine.h. Here we have to define what is the functions that we will use in washing machine.c. We have to define here. Then we will go to the source files. Here we have source file. First CLCD file, we have to define key functions like CLCD push and CLCD print. Here okay. Then we have digital keypad.c. Here we have to set what is a long press and short press. Less than 10 count I am taking a short press. Greater than 10 presses, 10 count I will take as a long press. Then I have ISR.c. ISR is an it's a function. It will automatically calls when there is a delay. It will generate a delay from 296 of 8 bits timer by taking 250 as timers. In timers we have taken, sorry, we have timers, we have taken PRQ as 250. So we have to set here 250 with calculations of 8 bits and 296 for 1 second. Then take as a count to 20,000, decreasing timer and decreasing timer. So we have decrease seconds and decrease minutes. Then we have main.c. Here initially we are taking washing machine program. Here initially we are taking buzzer as output and fan as output, and also buzzer and fan are turn off while initially. Then we will displaying the first screen as press 5 to power on washing machine till first screen. Then it will go to the second screen. What is second screen? Here what is second screen? Power on screen. It's a clear screen, and then it will display power on screen. What is the power on screen? I will explain in washing machine.3. Then if the power on screen is happened, then it will next go to the long. If the long press is happened and operational mode is washing machine screen, it will go to the water level screen. They have 5 levels of five different water levels. Then it will go to the water level screen. If the long press is happened in the water level screen, it will go to the start stop screen. Okay. Then switch case. Here switch case I have defined several functions and several states, several macro states. If the one case is happening, what will happen in that case? Here the wash program screen is selected. What will happen is what washing program display this function is called. If the case is water level screen, the water level screen will be activated. So that the different functions that I have written here will be written in washing machine.c for simplicity purposes. Here I will explain one by one. Here taking washing programs as this 12 and water levels as these 5. The program number to select one of the washing program, and water level unsigned care level to select one of this level, and second and minutes for timer, and total time, wash time, rinse time, spin time, time. The total time, there is a wash time of 42% for this until ventil, and it has no wash time for rinse and dry. It only has wash only mode and no rinse and no spin. It only has dry mode, only rinse, not spin and wash mode here, and etc. The while power on screen will be displaying blocks of continuous blocks, and delaying one by one. Then powering on washing machine, and we will setting washing mode. Next clear screen mode, here clear screen. Then wash program display. The wash program screen displayed, you have to move downwards when switch 4 is pressed. When switch 4 is long pressed, you have to go to the next screen. Here number 9 means when we displaying the three, we have choice of only display of 3 at the time. So when we select one program number 1, it will display these 3, and when we program number 2, it will display these 3. At the last, when the program is 9, you will display 9 here only. When what will happen is 10 is selected. So 10 is selected, there is a empty space below here. So we have to select this as here we have to select daily as this. So we have to set washing program 0 at the last position. So that will happen when program number is 10. When program number is 11, it will display wash and next the one, next one. Then water level screen, same logic here, only five difference. So we dividing 5. It's a logic here. In start stop screen, we have to go to next mode if switch 5 is pressed. And we have to go to the washing program screen if switch 6 is pressed. Then we have start screen. Next mode is start screen. When we play what is happening in start screen, it will display what is the mode that we are operating and what is the time required for this operating mode. And here we have to turn on the timer and turn on the fan, and also calculate wash time, rinse time, spin time from the total time. The total time here we have to calculate by using set time function. I will explain the last set time. Here we have set time. So when the program number is selected and water level is selected, then we have to set the time of every different things, every different modes. Okay, from here only we have the total time. Okay, from here on, see we from there only we have total time. In total time we have to select 40% as wash time, 12% as rinse time, and other 42% as spin time. Then we have pause. If we update cycle phase, it's another function that I have used. And also we have reset door check function. Okay. When timer here we are decreasing the time, and when the time is almost up and minutes is equal 0, seconds is equal 0, we have to clear screen and turn on the fan and buzzer to on, turn off the fan when the program is completed. And also we have to display program completed and remove screen. Then it will go to the wash program screen when the program is completed. Here we have to check door check when turn on the washing machine. Here RB0 is a macro. Here it comes from a data sheet of PIC16F877A. When door is on, then we have to off the time and off the timer and on the buzzer to warn the others. And also display door is open, please close. Okay. That's hi everyone. Here I will show my project demo. Here we have to select X5. Here I have selected washing machine production.h. Then we have to set megahertz as 20 that we have seen in the code. Then we have to select LCD as 4 into 2, not 16 into 4, not 16 by 2. Then here is the plus 5 to power on the washing machine. There are 6 keys and one non-used key. It is the first key, second key, third key, fourth key, fifth key, sixth key, seventh key. Here key, seventh key I am not using. And here key 5, G 1, 2, 3, 4, 5. I am pressing short press of key 5 to power on the washing machine. Then it will go to the washing program screen. We have 12 programs. I will scroll down one by one. You can see that when the short press is, switch 4 is pressing, short press is pressing, it should scroll down. Here we have daily. Then I am pressing switch 4. It will go to heavy. Then I am also then I am pressing switch 4, so it will go to dedicates, and then pressing switch 4, it will go to whites, and when switch 4 is again press, it will go to stain wash. And at the end of this we have dry only, then wash only, next aqua store. Then we have again the first mode, which is a daily mode. Then we have heavy mode. Okay, when switch 4 is long press, it will go to the next grid. So I am pressing switch 4 long press. It will go to water levels. Here we have 5 modes: auto, low, medium, high, max, and high. Again mode number 1, auto. Here I am pressing switch 4 to select the low mode, and I'll go to the next screen. It is a start stop screen. Here we have start stop screen. When we press switch 6, it will go to the wash program screen, and switch 5, it will go to the start program screen. So I am here pressing switch 6 to go to wash program, and then we will press switch 5 to start the screen. So first I will press switch 6, switch 3, 4, 5, 6 modes. This is switch 6. I am going to wash programs. Here also again I am selecting the heavy, so I have to press long press. Then I am selecting a medium, long press. Here I am here this time I will select switch 5 to start the program. So we have displayed the screen, and also the washing machine is on, and we are displaying the wash mode. Then we have timer, it is decreasing, and we are displaying start and pause. First I will stop pause this entire program by pressing switch 6. What will happen? Here we can listen. Switch 6, the fan is off, and the timer is off, and the program screen is displayed. Well, what will happen when switch 5 is on? Press it, the timer will be on, and the time will be decreased, and fan will be turned on. Okay, and here we can see that the rinse mode is displaying. Then we will have spy mode. Rinse, 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 rinse. Spy mode. Here I am pausing this. Wait a minute. Wait. So okay, I will select this again to open the door. start. Here the switch one is the door check. I am pressing door check. I am opening the door. When the door is closed, here timer is on and fan is on and buzzer is off. When the door is opened, buzzer is on, fan is off and timer will be off. And display door is opened, please open the door. Then we have timer decreasing. You can see that. When the program is completed, buzzer will be on. And the remove clock screen will be off on and it will go to the starting screen. Thank you. Challenges are learning. One challenge was configuring timer to for process delays. I also had to debug ISR routines and handling input filters. Throughout this, I learned the importance of timing accuracy, memory optimization, and modular code design. These experiences sharpened my problem solving and debugging skills. Conclusion and reflections. This project helped me bridge theory and practice. I gained confidence in embedded C, real-time system, and simulation tools. It also deepened my understanding of microcontroller-based design and system responsibilities. I am grateful to MITx for this opportunity and look forward to applying these skills in future projects. Thank you. Thank you for your time and attention. If you would like to know more about my project or discuss embedded system, feel free to contact me. I am Hemant Kumar Yanganti and this is my washing machine simulation using PIC16F877A.